So hello all. Today we will discuss about different language categories. So programming languages are categorized into four bins. That is, one is imperative, then functional programming languages, logic, and object oriented. So we do not consider languages that support object oriented programming to form a separate category of languages. Okay. So we have seen how the most popular languages that support object-oriented programming grew out of imperative languages. Okay, so we have compared this imperative and uh, object-oriented languages. So although the object-oriented software development paradigm differs significantly from the procedure-oriented paradigm, usually used with imperative languages. The extensions to an imperative language required to support object-oriented programming are not intensive. Okay. For example, the expressions, assignment statements, and control statements of C and Java are nearly identical. So that's what we saw. So similar statements can be made for functional languages that support object-oriented programming. So there is a relation between this imperative, object-oriented, or functional and object-oriented. So another kind of languages, that is a visual language, is a subcategory of imperative languages. The most popular visual language are, as we know, they are .NET languages. Okay, these languages include capabilities for drag and drop generation of code segments, and they are called fourth generation languages. And now they were actually called as the fourth generation languages. Nowadays we don't call them so. The visual languages provide a simple way to generate graphical user interfaces to programs. Okay, that is the main purpose of this visual languages. For example, using a Visual Studio to develop software in the .NET languages. Okay, so the code to produce a display of a form control, such as a button or text box, and that can be created with a single keystroke. And these capabilities are now available in all of the .NET languages. So some authors refer to scripting languages as a separate category of programming languages. Okay, so we can call this or we can categorize them into separate class, that is scripting languages. But the languages in this category are bound together more by their implementation method, partial or full interpretation, than by a common language design. So the languages that are typically called scripting languages among them are Perl, JavaScript, and Ruby. All these are imperative languages in every sense. Okay, so even though we have this scripting languages, some of them are, or you can call them as imperative languages. And a logic programming language is an example of a rule-based language. So as we know, in a rule-based language, for example, like this prologue, we have different rules or facts. Okay, we have some facts, and based on the facts, we can write some rules. And facts means they are well-known truths. And we have rules. These rules will have a left hand side and right hand side. So left hand side derives right hand side. That's what it's meaning. So in these in an imperative language, an algorithm is specified in great detail, and the specific order of execution of the instructions or statements must be included. Okay, that is imperative languages. So in a rule-based languages, what happens is rules are specified in no particular order. Okay, and the language implementation system must choose an order in which the rules are used to produce the desired result. So we have a list of rules and there is no particular order for them, and the implementation system must choose an order. Okay, and this approach to software development is radically different from those used with the other two categories of languages and clearly requires a completely different kind of language. Okay, and Prolog is the most commonly used logic programming language. And in recent years, a new category of languages has emerged. That is the markup programming languages. That is markup programming hybrid languages. Markup languages are not programming languages. For example, we have HTML. That is the most widely used markup language that is used to specify the layout of information in web documents. However, some programming capability has crept into some extension to HTML and XML. And among these are Java Server Pages, Standard Tag Library, JSTL, and Extensible Style Sheet Language Transformation, XSLT. And both of these are will learn about them later, and these languages cannot be compared to any of the complete programming languages. Okay, and a host of special purpose languages have appeared over the past 50 years, and these range from a report program generator, which is used to produce business reports, to automatically programmed tools, that is APTs, and which is used for instructing programmable machine tools, to general purpose simulation systems, that is GPSS, which is used for system simulation. Okay, and these are different categories of languages, even though we have mainly 4 bins: imperative, functional, logic, and object oriented languages. Okay, so we have some markup languages also. And next topic is about language design trade-off. And we have actually a framework for this language design, and this framework is self-contradictory. Okay, so in that case, the two criteria that conflict are reliability and cost of execution. Okay, so we have seen different criteria, evaluation criteria, and we have set up a framework for performing this evaluation and all. And these criteria or this facts are actually self-contradictory. So two criteria that conflict are reliability and cost of execution. For example, the Java language definition demands that all references to array elements be checked to ensure that the index or indices are in the legal ranges. Otherwise, or some overflow or underflow will happen. So this step adds a great deal to the cost of execution of Java programs that contain large numbers of references to array elements. So C does not require index range checking. So C programs execute faster than semantically equivalent Java programs, although Java programs are more reliable. Okay, so there is a trade-off between these two. So even though C does not require index checking, so if we need to have an index checking, that will incur cost of execution, but that will if we have this what do you say, this kind of index checking, C does not have this index checking, so C programs execute faster than maybe some semantically equivalent Java programs, but Java programs has this index checking, so that actually increases the cost of execution. And the designers of Java traded execution efficiency for reliability. Another example of conflicting criteria that leads directly to design trade-offs, consider the case of APLs. Okay, so APL includes a powerful set of operators for array operands, and because of the large number of operators, a significant number of new symbols had to be included in APL to represent the operators. Also, many APL operators can be used in a single long complex expression. And one result of this high degree of expressivity is that for applications involving many array operations, APL is very writable. Okay, so indeed a huge amount of computation can be specified in a very small program. And another result is that APL programs have very poor readability. Okay, so a compact and concise expression has a certain mathematical beauty, but it is difficult for anyone other than the programmer to understand. Okay, that's what we say. It has a poor readability because it has a compact and concise expression. So if we have a compact and concise expression, that is mathematically very beautiful, but it is difficult for anyone other than the programmer to understand. Okay. And I can say the designer of APL trader readability for writability. Okay, that is the most important thing. The conflict between readability and reliability is a common one in language design. For example, the pointers of C++ can be manipulated in a variety of ways which supports highly flexible addressing of data when we are using this pointers, and because of the potential reliability problems with pointers, they are not included in Java. Okay, and examples of conflicts among language design criteria abound. Some are subtle, others are obvious. Okay, so it is therefore clear that the task of choosing constructs and features when designing a programming language requires many compromises and trade-offs. Okay, so there is always a compromise required when we choose constructs and features of different programming languages. Okay, so that is about language design trade-offs. Thank you.